morning children. We'll continue the same function topic and some of the problems of the exercise will start. I have given you some of the questions of the exercise to complete an assignment. But it is sorry to say that out of the 17 children, only 8 are in regular for submitting the assignment. The rest of the students are not participating or not responding properly. See, this is for the present situation, this is only one mode of the teaching learning process. You don't think that the school will be opening immediately and then we can start from the beginning itself. And this is a step where we are making that some of the concepts should be cleared so that when the school opens, we can rush up the things and complete the syllabus of the entire academic year. Now I will try to solve some of the questions on the finding the invertible functions and inverse of the functions. Let us take the example, a function defined from r plus 2 minus 5 infinity. The function definition is fx is equal to 9x square plus 6x minus 5. The definition of the function is fx is equal to 9x square plus 6x minus 5. Now our question is whether this function is an invertible function. If it is invertible, what is its inverse? And we have the normal way of finding the way how the functions are invertible. We know that a function is invertible if it is 1 to 1 and 1 to 2. That is one way of taking. Another function is that if you are able to find out a function g, so that f dot g is equal to g dot f is equal to the identity. If such a function g exists, we can say it is invertible. So we will go ahead with such cases, and for that what we do is we mark a y is equal to 9x square plus 6x minus 5. And let us try to find out a next in terms of y, so that you get a function and another functions. Now here you can see that the function's domain is r plus, that means the set of all positive real numbers, and the codomain of the function is the interval minus 5, left closed and right open, minus 5 infinity. That is the codomain. And there is some specific reason for keeping this domain like this and codomain like this. Let us find out the x from here. You know that this is equal to 9x square plus 6x minus 5. We can write it as 3x plus 1 whole square. 3x plus 1 whole square, when you expand, you will get 9x square plus 6x. And there will be a 1 addition here. So that 1 and this minus 5. So we get 3x plus 1 whole square minus 6, that is 1. Let us find out the x from here, that is 3x plus 1 whole square is equal to y plus 6. Or 3x plus 1 is equal to square root of y plus 6. Or 3x is equal to square root of y plus 6 divided minus 1. Or x is equal to square root of y plus 6 minus 1 divided by 3. So now from this we find out y is equal to 9x square plus 6x minus 5, and later we could find out an x in terms of y. We can call this is a function as a g function or g of y. When g of y is mismatched, then what about g of x? Then g of x will be x plus 6 minus 1 by 3. Now let us think about that whether this g is always exists or not as per the domain and codomain given to us. You can see that if I take the value of x as some minus 7, then if I take minus 7 here, minus 7 plus 6, it gives square root of minus 1, and square root of minus 1 is not a real, it is an imaginary. So for more than say elements in the codomains are starting from -5 to infinity only. If it go beyond that one, there is a possibility that this function does not exist. So now at present definition for this domain and this codomain, this function exists. And let us see that what is f dot g from this one. We could find out a g and let us find out f dot g. F dot g of x is equal to f of g of x, and it is equal to f of g of x. G of x is square root of x plus 6 minus 1 divided by 2. So f of this one is to be find out. We know that fx is here is our fx. So f of the whole things is to be found out. That means in this function now we will be replacing x by these values. So it is 9 into root of x plus 6 minus 1 by 3 whole square plus 6x, that is 6 into root of x plus 6 minus 1 by 3 then minus 5. That is the value of f of g of x. Now let us simplify 9 into, when you take a minus b whole square, then you will get a square, it gives x plus 6 plus b square, that is 1, and then minus 2ab, minus 2 into x plus 6, okay, divided by the square of it becomes 9, and this 9 get cancels, and here this will be getting cancels 2 times, so 2 into square root of x plus 6, then minus 2 minus 5. You can see that minus 2 times root of x plus 6 and plus 2 times root of x plus 6 will be getting cancels. 6 plus 1 7, and this 7 goes cancels, and finally your answer is this x alone. So you could get that f dot g is of x is equal to Lx. That means it is an identity function. An element, this composition function taken x to x, that means it is an identity function. That means you have proved that f dot g is I. Similarly, you can prove that g dot f is also equal to I. So finally, you have reached a state that f dot g is equal to g dot f is equal to I. Fine. So it satisfies the definition of the function. That means we could find out a g. The composition of f and g and g and f is coming as I. So we call g is the function inverse of f, or g of x is the inverse of the f, and the f inverse x is equal to, what is the g of x here? This is the inverse, that is root of x plus 6 minus 1 by 3. So this is what the inverse of this function, and thereby we are able to prove that the function f r plus 2 this one, it is an invertible function and its inverse is this one. Okay, so this is what that is what invertible function comes. And let us take one more examples. And this is a problem in your textbook of I think question number 12. I will take you one more question for that one. That is, f is a function from x to y, and f is invertible. Then if f is invertible, then prove that its inverse is unique. The uniqueness of inverse. This is what we have to prove, that f is an invertible function and it is to be proved that it has only one inverse. So for this proof of this one, we will take it some other way. Say let g1 and g2 are two inverses. We want to prove that it is having only one inverse. So for proving that uniqueness, let us take G1 and G2 are the two inverses and let us see what is going to happen. Since G1 and G2 are the two inverses of F, that means G1 is one of the inverse of F and G2 is another inverse of F. So it shows that F dot G1 is equal to height because it is the inverse of this one, and G2 is another inverse. So F dot G2 is also equal to, because we have mentioned that both are the inverse of this one. You can see that F dot G1 is equal to I and F dot G2 is equal to I. From that we will get that F dot G1 is equal to F dot G2. That is F dot G1 of X is equal to F dot G2 of X. What it means? As per the definition of the composition, F dot G1 of X, it means that F of G1 X. And F dot G2 of X, it means that F of G2 X. We have started with the case that F is an invertible function. And we know that every invertible function is one-to-one. That is, F is a one-to-one function. What is the meaning of the one-to-one function? That means if F is a one-to-one function, F of x1 is equal to F of x2. It implies that x1 is equal to x2. This is the meaning of a one-to-one function. So it is, since F is an invertible function, F is one-to-one, and the one-to-one definition implies that F of x1 is equal to F of x2, which gives x1 is equal to x2. So here F is a one-to-one function. This is equal to this. That means these two are equal then, because of the one-to-oneness. So G1x is equal to G2x. So you are getting G1x is equal to G2x. That means the function G1 and function G2 are equal. We have started with the cases that G1 and G2 are two inverses of F, and finally we ended up saying that G1x is equal to G2x. That means both are same. It shows that the inverse is unique. Inverse is unique. So we have given two questions today. The one is first one, proving the inverse, finding out the inverse of this one. And now let us go to one more question of this today, and then I will use some of the exercise problems to you. The other one is a third question. F is a function from x to y. Then prove that F inverse is equal to F itself. This is the question. Now you know that F is a function from x to y. So F inverse will be function from y to x. Then F inverse, it will be a function from again x to y. So F inverse is a function from x to y. F is also a function from x to y. Now how this F inverse is coming as F? Let us check that one. F of let y is equal to F of x. Then F inverse y is equal to x. That is F inverse. And taking its inverse again. It will be from again y. Y is equal to F of x. F inverse y. That means the inverse of this will be x. And taking the inverse of x again under this one, inverse of this one, and F inverse is equal to y. So F inverse is equal to y is equal to F of x. Okay, now you can see that F inverse here. This also both are same. F inverse is equal to F. Just repeat it. Y is equal to f of x. So F inverse will be y. F inverse y is equal to x. Taking the inverse of it again, use y and we know that y is equal to f of x. It shows that F inverse or inverse is equal to f. And we could prove that f x to y, then F inverse will be equal to f. So with this I will wind up today's classes and some assignment. Just I will note down and give you, or I will send this as a PDF mode to you. So here some 5 questions are written as assignment and another 3 questions also marked. So totally 5 plus 3, 8 questions are given as an assignment today. And by tomorrow itself we must submit it. And one more thing is that with this relations and functions is closed, is over. Now the next day we will be starting with the or revising the inverse trigonometric function. Thank you.